Welcome friends. Our next topic is generation of FM wave. For the generation of FM wave, two methods are generally used. First is direct method and second is indirect method. Also, we know that in frequency modulation, the instantaneous frequency varies linearly with the massive signal. And the relationship is instantaneous frequency equals to carrier frequency plus kf into mt, where kf is called frequency sensitivity of the modulator measured in Hz per volt. Now first we talk about direct method of generation of FM wave. This is also called reactance modulator. In this method, the FM wave is generated by using a device called voltage controlled oscillator or VCO. VCO is basically a sinusoidal oscillator having capacitor as a reactive element. In voltage control oscillator, the frequency is directly controlled by the massive signal, that is voltage signal, because we know that massive signal is typically measured in volts. So in direct method for generation of FM we use voltage control oscillator. Here the control signal is massive signal, that is called voltage signal. As shown in figure, the Hartley oscillator is used for the generation of FM. That is the direct method. It is a type of voltage control oscillator. It consists of transistor, inductors, L1 and L2 and shunt capacitor. In this combination, we assume that the capacitor has also shunt arrangement. Here, fixed capacitor and voltage variable capacitor are arranged parallel and measures the instantaneous value of capacitance, that is denoted by C function of t. And by using this value with L1 and L2, we can determine the frequency of oscillation. Frequency of oscillation can be determined in terms of instantaneous frequency, that is equals to 1 upon 2 pi under root L1 plus L2 into C function of t. So here frequency of oscillation is directly used to determine the instantaneous frequency for FM wave, which is equals to 1 upon 2 pi under root L1 plus L2 into C function of t. Here C function of t is called instantaneous value of capacitance and it is equals to C naught plus delta C cos 2 pi FM t. Here C naught is the total capacitance in absence of modulation and delta C is the maximum change in capacitive value after modulation. Now substituting instantaneous capacitance in the formula of instantaneous frequency, that is called frequency of oscillation. So instantaneous frequency equals to 1 upon 2 pi under root L1 plus L2 into C naught plus delta C cos 2 pi FM t. Now we take C naught outside the bracket and after this arrangement we have 1 upon 2 pi under root L1 plus L2 into C naught into under root 1 plus delta C upon C naught cos 2 pi FM t. Here 1 upon 2 pi under root L1 plus L2 into C naught is called unmodulated frequency of oscillation and it is denoted by F naught. And the expression become instantaneous frequency equals to F naught within bracket 1 plus delta C upon C naught cos 2 pi FM t whole to power minus 1 upon 2. Here we move under root from denominator to numerator. So the power become minus 1 upon 2. Now we assume approximation, that is delta C is less than C naught. So after assuming delta C is less than C naught, we get the approximate instantaneous frequency, that is equals to F naught within bracket 1 minus 1 upon 2 into delta C upon C naught cos 2 pi FM t. Now again for our convenience we assume minus F naught delta C upon 2 C naught is equals to delta F, because here delta C is very small and make the whole term also very small with unit of frequency. And after this assumption, we can write delta C upon 2 C naught is equals to minus delta F upon F naught. This relation shows that the increase in capacitance reduces the frequency of oscillation because there is a negative sign. And instantaneous frequency can be written again in terms of delta F. That is, instantaneous frequency equals to F naught plus delta F cos 2 pi FMT, and this is the desired relationship for instantaneous frequency of FM wave. Here F naught is called total frequency in absence of modulation and delta F is called maximum change in frequency after modulation, and it is called frequency deviation. So by using this method, narrowband FM is generally produced. And in order to obtain wideband FM, frequency multiplier can be used. The input of the frequency multiplier is narrowband FM, having Fc plus minus delta F, where Fc is called center frequency or carrier frequency, while delta F is frequency deviation. And at the output of the frequency multiplier, we have n times of carrier frequency, also n times of frequency deviation. That is called wideband FM. Also, if narrowband FM having modulation index beta, and after passing through frequency multiplier, we get n times of beta. That is wideband FM. Next method for the generation of FM is indirect method. It is also called Armstrong modulator. In indirect method, the message signal is first used to produce narrowband FM, and then we use frequency multiplier to increase the frequency deviation as per our interest. So there is a difference in both direct method and indirect method. In direct method, we generate narrowband FM directly using the instantaneous frequency. That is called frequency of oscillation. But in indirect method, our input is message signal. So we first generate narrowband FM by using integrator followed by a narrowband phase modulator having a sinusoidal carrier signal as another input. Here the sinusoidal carrier is generated by crystal controlled oscillator that provides frequency stability to the whole system. Here the first part, that is generation of narrowband FM, have already discussed in our last video lecture. And this narrowband FM get converted into wideband FM using frequency multiplier. And this whole combination is called indirect method of generating a wideband FM using phase modulation technique. But there is a problem in indirect method. In indirect method, there is a possibility of distortion in phase modulator. So in order to minimize this distortion, the modulation index beta should be kept small. And we know that when beta is small, the result is narrowband FM wave. And again, to get the wideband FM, we use a circuit called frequency multiplier. Frequency multiplier basically consists of a memoryless non-linear device followed by a bandpass filter. This bandpass filter having a midband frequency of n into Fc. Now, the input of the frequency multiplier is narrowband FM wave, that having a modulation index beta and carrier or center frequency Fc. Also, the output of the memoryless nonlinear device is V function of t. And after passing through bandpass filter, we get a wideband FM denoted by St dash, having carrier frequency Fc dash and modulation index beta dash, both having n times of narrowband FM. Now, we explain this mathematically. First, we consider memoryless nonlinear device. Memoryless means it has no energy storing elements such as inductor or capacitor. And the input-output relationship is in the following form, that is, output of nonlinear device is V function of t, and it is equals to a1 st plus a2 st square plus up to an st to power n. Here st is the input called narrowband FM wave, and a1, a2 up to an are called coefficients having n as highest order of nonlinearity. Also, the equation of input, that is narrowband FM, is given by st, that is equals to AC cos within bracket 2 pi fct plus 2 pi kf integration m tau d tau. Here the instantaneous frequency is equals to fc plus kf into mt. Here kf is called frequency sensitivity of the modulator. Next, after passing through band pass filter, we get new FM wave called wideband FM, and it is defined by st dash, that is equals to AC cos within bracket 2 pi fc t dash plus 2 pi kf dash integration m tau d tau. Here fc dash is equals to n times of fc and kf dash equals to n times of kf. And accordingly, the instantaneous frequency of wideband FM is fi dash, that is equals to n into fc plus n into kf into mt. Here n is called the frequency multiplication ratio, that is determined by the highest power in the input-output relationship, which represents the memoryless nonlinear device.